Hey everyone, I'm Sabrina Ramonov, and in this video, I'm going to walk through two amazing examples of AI agents before LLMs, before ChatGPT. I'm going to explain how deep reinforcement learning, the technique, was used to train these agents and how they work. And for those of you who are not super familiar with the term AI agents, just know that they've been around long before LLMs, long before ChatGPT. You can think of an AI agent as an autonomous entity. So it's doing its thing without anyone intervening, and it gets feedback from its environment. It's learning from interactions with its environment in order to make decisions and achieve certain goals, certain objectives. So again, before ChatGPT, before all of this generative AI stuff, we were already surrounded by AI agents like voice assistants, Siri and Alexa, and chatbots as well, customer support, customer service chatbots. Although these agents were more rigid, not as flexible and adaptable as what you could build today with large language models, they were still AI agents. So the first AI agent I'm going to show you, he's called Huggy. It's basically training little Huggy to learn to play fetch. And he was trained using deep reinforcement learning. So let's go ahead and load our Huggy model. Monini. Okay. All right. And here we go, the simulation is starting. So you can see Huggy there bopping around. And basically the goal of the simulation, where'd Huggy go? Huggy needs to learn to move correctly towards the stick based on the information he gets from the environment. And so in reinforcement learning, the state space is basically what the agent perceives. In this case, Huggy isn't visually perceiving the environment. He only gets three pieces of information. So the position of the stick, which is like his goal to get to, the relative position between where he's at and where the stick's at, and also the orientation of his legs. So the hard part here is like Huggy needs to figure out how to move the joints in his legs in order to get to the stick without like excessively spinning. You can see it kind of takes him a while to fetch the stick. And in formal terms, kind of the action space here is the set of all possible moves Huggy can take. Since his movements are controlled by joint motors driving each of his legs, the action space is basically like all the possible ways Huggy can rotate the joint motors of each leg to move towards the stick. And then the reward function obviously is it's what reinforces desirable behaviors and then penalizes undesirable behaviors. In this case, fetching the stick, little Huggy gets a reward. So he wants to do it again and again and again. So you can see here, I keep throwing the stick, and at each time step, Huggy has to kind of observe the environment, which are those three data points I mentioned earlier, and then decide how to rotate each joint motor without going into like some crazy spin. Oh no, Huggy's spinning. Come on, Huggy, you can do it. Yeah. Oh, yeah. I actually have a puppy named Hugs, so I thought this simulation was particularly relevant for me to share. Come on. You can do it, Huggy. Come on. You can do it. I want to talk a little bit about like what is deep reinforcement learning and how is everything working here. So I'm actually writing a blog post accompanying this video, and there is a short section on what deep reinforcement learning is for those of you not familiar with it. It basically combines reinforcement learning with deep learning, which is why it's called deep reinforcement learning. And you can think of reinforcement learning for any of you who have pets, giving your pet a treat for good behavior and punishing your pet, for example, with a timeout for not very good behavior. That's basically what reinforcement learning is. And then it combines it with deep learning, which is basically using neural networks with many layers. And in this particular context, the neural networks are used to approximate value functions or policies. Those are components of deep reinforcement learning, which I tried to list out here, really trying to make it simple for folks who might be newer to this subject. So let's think about our Huggy simulation. The agent is obviously Huggy, because Huggy's learning and making decisions on how to fetch the stick efficiently. The environment, you can see the environment here. And although it's visually represented, just remember Huggy can't actually visually see this environment. In our next example, I'm going to show you an AI agent that is actually analyzing like pixels on the screen. And remember, in this simulation, Huggy only has 3 pieces of information from the environment at each time step. Number 1 is the position of the stick. Number 2 is his relative position between himself and the stick. And then number 3 is the orientation of his legs. And then the state, so that's like his current orientation of his legs. The action space, this means all possible moves the agent can take. In this particular case, the action space is the set of all possible movements that Huggy can make with his joint motors, which drive his legs. Reward, that's feedback from the environment. So again, when Huggy successfully fetches the stick, he gets a positive reward. So he learns that he should do that again. And he should, move his legs in such a way to achieve that outcome again. Policy refers to the strategy used to determine your next best actions, and the value function is the prediction of future rewards. I'm not going to get too much into those two. And so how you can think of deep reinforcement learning in a really simple way is like Huggy is out there learning about its environment, that's called exploration, and then uses that information to make decisions to get what it wants. That's called exploitation, maximizing rewards and minimizing penalties. Through a lot of repeated interactions, we basically have to play fetch with Huggy a lot of times. But eventually, Huggy learns from the rewards and penalties it gets, and it's adjusting its behavior, its policy, to improve its performance. And then the neural networks, where that comes in, which is the deep part of deep reinforcement learning, the neural networks here are used to approximate the policy or value function. And so let's go back to Huggy. And if you guys want to test this out yourself, in the blog post and in this video, I'll link to where you can test this out, hosted by Hugging Face. Come on, Huggy! Yeah! Oh, kind of like almost picked it up and then threw it away. Come on, Huggy, yeah! So yeah, this is a really fun simulation, and this is an example of an agent that is not using LLMs. Okay, this is an AI agent trained via deep reinforcement learning. It's not powered by ChatGPT, LLMs, or anything like that. And this is just to showcase that agents have been around for a long time. What makes LLMs particularly interesting is now you can build agents that are more flexible and adaptable to diverse situations that they haven't seen before. Because one challenge with agents prior to generative AI is generalization to like tasks and environments and situations it hasn't seen before. So for example, think of like chatbots. We've all talked to chatbots on websites and have been very frustrated by the kind of rigid, canned responses. Whereas with generative AI powered chatbots today, like they're much more flexible. The language is believable. They can interpret your concerns in a way to find relevant information. All right, the next AI agent I'm going to show you is a Doom AI agent, like Doom the video game. Let me expand this to full screen. And basically, this AI agent is trained to figure out how to survive. But at the start of the game, it doesn't know what is going to help it survive. The only things it knows are that surviving is good and dying is bad. So eventually, this AI agent learns through repeated interactions with its environment that these medical kits or med kits, replenish health, and health is connected to survival. So health is good because it helps it survive. Even though we didn't tell it to pick up med kits, we didn't tell it what med kits are. Really, the only thing it knows is that staying alive is good and dying is bad. So it eventually learns med kits, replenish health, and also it learns that health is required for survival. And this is a really cool library that it uses. Let me just close the screen. It's called VizDoom, which is an open source Python library that anyone can use, and it's primarily developed so that you can train AI bots that play Doom. And it has all different levels and stuff. This particular level that I was playing the video for is called it's called the health gathering level, right? So over time, again, the AI agent needs to learn that health is required for survival and medical kits are what replenish health. But there's all sorts of levels you can do, like there's shooting levels here, if you can see this little GIF, all sorts of scenarios. Yeah, the scenarios here like defend the line, deathmatch, my way home, take cover. So all sorts of stuff you can do to train AI agents. And just going back to the video real quick. So in this context, this AI agent is different from the previous one. One big difference is that it's actually analyzing visual information only. So it's actually analyzing the pixels on the screen to figure out like, oh, it needs to go to these weird looking white boxes, and that it replenishes health. So that's a big difference from the previous AI agent, Huggy, where even though it's at a very nice, pretty background, Huggy did not actually visually perceive the environment in any way. It only got, those 3 data points that I mentioned earlier. Whereas here, this AI agent playing Doom is visually interpreting and analyzing pixel by pixel what to do next. And in terms of the environment, basically there's a map, which is just a rectangular space with walls. And this green floor is actually like an acidic floor that occasionally depletes the agent's health, the AI agent's health. And then there's these med kits kind of scattered throughout the map. And then basically the episode ends when the agent dies or after a certain timeout period. And just to give you guys a sense of like what some of the variables were, again, I'm gonna write this up in a blog post. These are some of the configuration details for training the AI Doom agent. So it gets a reward, like 1 point for living, which helps incentivize survival, which is the behavior we want. There's a penalty for dying. It's a pretty severe penalty. So 1 point for living, 100 points for dying. And this is really meant to teach the agent not to repeat the actions leading to its downfall. In terms of the action space, again, that's just a formal term for like what are all the actions the agent can possibly do. There's only 3. It can turn left, it can turn right, it can move forward, like a video game, but it doesn't have like jumping or crouching or any of that. And then the variable that it does know is health, but it doesn't know at the start that health is connected to survival. And it doesn't know at the start that those med kits heal you. If you want to learn more about this particular agent demo, I'll drop the link in the description as well as in my newsletter. But you can play around with it here via Hugging Face. You can set it up yourself as well. And you can learn more about, what goes into training the agent and also about the different levels that you could potentially do in VizDoom if you're interested. So that concludes my 2 kind of walkthroughs of these AI agents. I really love this one. It's so calming and like Zen meditative. Come on, Huggy. Which reminds me I should probably go play with my dogs right now. So thanks for watching. I'm Sabrina Ramonov. And to summarize in this video, I shared 2 AI agents that were trained via deep reinforcement learning. Before ChatGPT, before LLMs, agents have been around for a really long time. And these are just 2 examples of them. If you like this video, please hit like, comment below. Look forward to hearing from you.